Hi everyone, welcome to another Tiny Experiments. So, had a bit of a run on those Pondering Mage episodes and got that out of my system. So we're back on the Tiny Experiments now. Hopefully, from what I covered in there, you'll sort of see what happens before I get to experimenting. So the sort of pondering process that goes on in order to give me ideas to try out with generative AI and other coding things. So for this episode, I'm going to be talking about, talking around this acronym, RASCEF, and we'll go through in a moment. We'll see what this represents when you're doing prompting in generative AI. Specifically for these experiments, I'm going to be using Google Gemini. And if you want to run this, you'll obviously need Python on your system. You won't need any special libraries. All the ones I'm using are all built in, or at least built in to my install of in my base install of Python. So that's Python through Anaconda. I'm using requests here to do the API requests. I could have used the Google Gemini library to do that, but I chose not to. I just wanted to dial back a layer of abstraction and you get to roll my sleeves up a little bit. So this is another one of these sort of half and half code productions. What I tend to do now is I've got a version of my basic request response for Google Gemini. There's a script I have for that, which I went through in an earlier episode, which I literally sat down one day and built from the ground up, just to sort of reacquaint myself with how you do it through the request library. And then from that, I refactored it into something more idiomatic to Python. So it's been through the ringer a few times. And what I tend to do now is if I want to build wrappers around Google Gemini requests, I give that to the LLM and then say, okay, this is my starting code and I'd like to add in the following features. And then I see what it comes back with, tweak it a bit, make sure it hasn't messed up the API. JSON response, which sometimes happens, but generally if you give it the base code with all the correct sort of JSON structure, as granular as you need it in terms of the settings, whether you're using system instructions, if you're using search grounding, what you want to do with thinking, those sort of things. So they're all in my base code. So generally I find doing that I get better results now when I try and create wrappers for things, because it's already sort of showing the model this is exactly how everything's laid out. So what I then did is I then started to riff around ideas to do with this RASCEF, which is down here. You can see what the R is role, the A is action, okay, the S is steps, the C is context, the E is example, and the F is format. Now I've jumbled these up a little bit for various reasons, because sometimes you tend to, if you played around with these and haven't realised the way in which you might have used them, maybe the order might be different from the acronym. So we've got some experiments that basically take just the action and then individually, not cumulatively, but individually add, say, a role to the action, or a context to the action, or a format to the action, or example to the action, or steps to the action. And then we get into the combination. So we've got a role, action, format, action, context, example, role, action, steps, context, and then finally the full RASCEF, role, action, steps, context, example, format. And I'll break this down so it's really clear exactly what's going on here. Now you'll see what we've got is a list here of data, which is, you know, composed. You can see here's the experiment class up here. So we have name, focus, text, and the fourth one, instruction. But obviously, if I'm not using instruction in the experiment, which I'm not always, I don't need to have that present. And what it does is there is a instruction. The instruction is set to blank. So if there is no instruction, it assumes that we're not giving it a system instruction. So it defaults to an empty string. So if I don't specifically set it, it's always going to be an empty string. So you can see there's all the experiment parts here. So just to go through this, our action is explain what a CPU is. That's our base action. Then if we modify, well, here's the thing. So we've got a couple of choices here. You can add a role to the text. One way that people tend to do it, you don't always have to do it this way, because in some models the system instruction just gets concatenated onto the text anyway, the prompt. But for this illustrating here, what I've decided to do is the role goes into the system instruction. And yeah, what I'm talking about, that when I say a role in the system instruction, it's the usual thing like you are a something, you are a friendly expert. Now, what's interesting about this is clever use of instructions and prompts. You can get the system to do some interesting hallucinations or some interesting results when the instructions sort of conflict with the prompt. And the reason why that's useful is because sometimes it comes up with some interesting side effects, but also you get to see what happens if you're not careful with making sure your system instructions synergize with your actual prompt. So generally I've found that if you are going to use system instructions, try and be artfully vague. So here we're saying you are a friendly expert explaining a concept to a complete beginner. Be patient and use simple, non-technical analogies. Okay. So that way, if later down the line in these experiments you wanted to play around a bit with the text, it's going to be a little more synergistic than if we'd said something like, you are a friendly computer expert, and then we decide to change this as part of a later experiment from something no longer about CPUs, but to something like non-computer based. Now, we could also maybe get rid of this, but we don't, but it doesn't really matter, I don't think, if we are going to ask for a non-technical subject anyway. We're just sort of doubling up, really, saying, explain in a non-technical way whatever this is, and this could be a non-technical subject, but here it is a technical subject. But my point is, when you're doing these, any experiment, anything you might do, not just this one, make sure that you understand the relationship between your system instruction and the actual prompt, and whether they're working together or whether they're conflicting. And like I said, you might want them to conflict in certain situations where you're experimenting with hallucinations, or you're experimenting with certain strange sort of creative techniques. So for this one, just adding in a role, we're simply adding in a system instruction which is going to get pushed into our request at a certain point, and these are all just getting loaded up ready to be used. These experiment definitions. So we got one here, we're adding context. So for this one, we don't need any system instruction. We're not going to bother with it. We're just looking at what does it look like when we have an action and a context and a blank system instruction from our end at the very least. So here we're doing explain what a CPU is, And the context is I'm writing a purchase guide for gamers, so on and so forth. So here, the context is going in with the prompt text, the main prompt text. And that's another thing I've started to do. I'm tending now to dial back the system instructions a lot more with stuff I'm doing. You can load up some of this stuff into the system instructions, actually. I've done that before, but I'm finding now, because of conflicts I have and it becoming a bit too specialized, I've started to simplify my system instructions to things like, you are a friendly expert, or what was the other one I use a lot? You are a friendly AI with a flourishing demeanor, or something along those lines. So it's more like a base level personality. Like I said, you can get super specific, but just be aware of the implications of doing that. So we're adding in context, no system instruction. Here we're adding in a format, nothing else apart from the action. So explain what a CPU is, provide the output as a JSON object with 3 keys. So we're being really specific about the format. Provide an example. So we've got action with example. So here we've slightly changed it just to make things a little bit more interesting. Here we're asking it to provide a 1-sentence poetic definition for a technology concept. And then we're giving it an example. And then now do the same for a CPU. So we've swapped things around here. So it's still about a CPU, but we're sort of turning it on its head and have that at the end, because we want to make sure sort of up front what the example is. Now you could argue that this also has some formatting stuff in it as well. So you sometimes find that example formatting steps and other things sort of slightly overlap, so it's not always clear cut, and sometimes you might want to mesh them in together to make it run smoother. We could just say provide another poetic definition here. So we have got a little bit of formatting seeping in, but it's really just to make sure that it lines up with the example better. That's why. So it's really just reformatting the example, or making sure it follows the example. So it's reflective of the example, if that makes sense. Experiment 6, outlining steps. So this is where you might go through, explain step by step. But the nice thing with steps is you can be super specific. So it almost, again, becomes almost format in nature, but these are steps to go through. So start with the full name, provide a 1-sentence analogy, list its 3 main tasks in bulleted list. But again, you'll often find when you're doing this, steps can sort of interact with formatting as well. You could do something simple like, explain in a step-by-step fashion, but it's quite nice if you have this thing, sort of do this, then this, then this. And again, you can try out by stripping this down and just, say something like explain what a CPU is in a step-by-step fashion. But we're asking it specifically what those steps should be. And then we get on to combinations here. So role, action and format. So we've got system instruction. You're a project manager creating a task ticket. So we're getting super specific here. Describe the task of learning what a CPU is. Format as a markdown checklist. Then we've got action, context, example. Generate 3 different advertising slogans for a new ultra-fast CPU. The target audience is creative professionals like video editors and 3D artists. Example style. Think faster, create faster. Now generate 3 more in a similar style. Then we've got role, action, steps, context. You are a helpful tutor creating a study guide. So there's our system instruction. And then we've got create a study guide entry for the CPU, so it's just part of it. The student is a visual learner and finds text boring. Create a title for the study guide section. Use a simple emoji to represent the CPU. Explain its function in one short sentence. So we're sort of layering on this these steps in which it should do it. So we've got our role, our context, our action. They're again sort of meshed in there, intermingled if you like. And then the steps, we would like to do that. And again, yeah, might be slightly spilling over into formatting. But with formatting, I tend to think of it more of where you're specifically saying, you know, format this as a text file or format this as JSON. That sort of formatting. But again, the lines can be a bit blurry here. And then the full RAS. So you are a script writer for a popular tech YouTube channel that makes complex topics simple and fun. Write a 30-second video script intro about the CPU. The goal is to hook the viewer immediately. Follow this structure. Start with a reliable question. Briefly state the CPU's nickname. End with the promise of what the viewer will learn. Example of a line you might write. It's the brain of your computer, the master chef in the kitchen. The final output must be in plain text with no special markdown. And again, you can see here, we could have laid this out differently, but I've got some new line characters here to space it out a little bit nicely when the request goes in. So it's a bit easier to see and lay it out for when it's input or pulled into the request. And we have our cool Gemini API. So doing a request to the Gemini API for a given experiment. We've got our system instructions going in. There's where our contents goes. We've got our temperature, our top P and our top K all hard coded in. And these are the sort of default settings for Gemini Flash 2.5 from what I remember. Yeah, I think they are actually. And then we've got Google search. We're not telling it. We're using here we're using default thinking, so any thinking settings are just decided by the model, but we have got Google search grounding on because we're asking quite technical questions. Very simple error catching. We've got some writing to files here. We're appending to this file, so it'll, if the file doesn't exist, it'll create it. And yeah, it's just where the thing you saw at the start there, what it was going to be called. So we've got, where was it? Yeah, RASCEF _ experiments.md. There we go. Yep. So some title stuff, the user text that's going in, system instructions if they're going in, various other details about the stuff. Response that's coming back, capturing, making sure it captures the parts, okay, so you don't miss stuff out there. Some error handling, extracting the web searches if there were any, done. And then just the main bit here. So we're just checking if the output file already exists, if we're writing the header multiple times. And then use a session object for connection pooling and efficiency, which I don't think is something I've done before. So we're appending it. If the file is new, write the main header. If it isn't new, then don't. So there's just a main header here. And then any future experiments just get appended to the file. if you want to run them again or play around with the context and instructions and various other bits and pieces and try other things, you can just keep loading up multiple experiments. You can load up extra ones and add on more, and then when you run it, it just churns through them all. So let's run it and just see what's going on. And there's nothing to input here, it's all just self-contained. So first up, we're doing a baseline just action. Now obviously we're doing 10 requests here. So, you know, for me, with the amount of experimenting I do, I don't run into problems. But just a heads up, if you know you're using the model and you do use a lot of requests, and obviously each one of these is a request off of your allowance. I mean, I just use the free one because why not? So you can see it's sort of cranking through here all the different experiments. We're up to what, experiment 4 here. Now the other thing you could do, I haven't done it here, is you know, you can do some interesting things with timeouts and re-requests to avoid any problems, catch errors that way, but the error checking here is pretty minimal. And some of the code I might do in the future, I might do a bit more of that, of, you know, things like retries and various other things. So you can see this is building the, there's the RASCEF experiments MD, and we're good to go. So if we have a look at this and go in, you'll sort of see what to expect. And then we have a run. Now if I do another run, it's just going to append on the bottom. So here's our, you know, explain what a CPU is. There's our response. There's the search queries it considered. Then we're going to add a role, and that's the response we got. Those are the search queries it considered. Then we added context. You can see there's no system instruction for that. And so each time you can see, hopefully, and you could even do things like you could run the same experiment multiple times and see how consistent the results are, and even change or fiddle around with your hard-coded settings. Now remember, the settings are the same for every single experiment in terms of the temperature, top K, top P. But the only thing that changes is the context, basically. So we are, you know, doing context engineering effectively here, if I hadn't mentioned that term already. So adding context, and obviously depending on the sort of things we're doing, we're going to get vastly different results. So here we're actually asking it to return a JSON object, and here's our JSON object. And again, those are the search queries it considered. There's our poetic definition, helped by providing an example. So you can see it's laid it out similar sort of way. You can see there from that example. So like I said, you know, examples will obviously affect certain aspects of formatting in, you know, speech marks, air quotes. But in this example, you know, where we're talking about formatting, this is the sort of formatting we're actually talking about. This style of formatting. Outlining steps. So, you know, suggesting how it should break things down. Again, certain ones of these will contribute to the way things are laid out. So, you know, another type of formatting, I suppose. 3 main tasks are So he's often referred to as a brain and computer, yeah. So role, action and format. So here we're formatting it as a markdown checklist for learning purposes. That's pretty cool. Nicely laid out. Combining action plus context plus example. Three advertising slogans. Role, action, steps, context. And remember here, we were pretty specific. So we gave it a load of stuff. We said, this is the system instruction, but in actual fact, all we want you to do is create a study guide entry. So using just create a title, use some sort of emoji, and explain the function in one short sentence. So here we're giving it, in essence, probably more instructions than we're getting back here. Sort of narrowing it down. And then full RASCEF. And again here, we've got a lot. It's 30-second video script intro about the CPU. And here it is. Ever wonder what makes your computer, phone, or even your smart fridge actually think? That, my friends, is the work of the CPU, the central processing unit. It's the brain of your computer, the master chef in the kitchen, the tiny genius crunching numbers at lightning speed. In a few minutes, we'll demystify this essential component, showing you exactly what it does and why it is so important for everything you do online. Stick around. And this is an interesting thing to think about, because often when we're doing requests to large language models, we're keeping our prompts pretty simple and we're churning out a ton of stuff. But what you can do is you can do this sort of more, so the more you tell it and shape it, the less it's going to pump out, because you're sculpting the answer in a certain way. So with this, we're giving it a role, we're giving it an action, which is to do with 30-second script about CPU. Also within that there is context, and we've got some steps to go through and an example. And it's actually just in fact it's re-quoted that, which is interesting. So it's actually grabbed that. So you might want to try this experiment with a different example, which is more analogous with it. Is from a different domain, maybe. Similar to the one we did earlier, something like that. So it's interesting things to play around with. So here it actually has grabbed the line. And in other ones you might have a really neat line you want to use, and you might want that embedded in, which has happened here. And you could say that what's happened here, and it is implied again, it's more a sort of combination of the implicit and the explicit, in that you've got this master in the kitchen ... so it's finished that off there. So just think about, okay, what has it done here? Is it grabbing it, putting it in, by putting these 3 dots at the end? What if I hadn't have done that? You can do little tiny changes to your tiny experiments and see what they do. So as always, I will put this up on the GitHub page. I will include a link, and if you have the Python and a few other bits and pieces you're running, then you can play around and run this experiment too. So thanks once again for watching. Bye for now, and I will catch you in a future episode.